All right, today we're going to graph systems of inequalities. Now this differs from the graphing a system of equations because now we're dealing with inequalities. So we have some basic differences between graphing an equation and inequality. But you've done this before. As one of my students in my classes yesterday astutely made the assertion, hey, this isn't anything new. No, it's not. We learned this, how to do graphing an inequality in Chapter 6. The only difference is now we're going to have two inequalities on an individual coordinate plane. So our basic difference, I lost it again. Our most basic difference, there are two major ones. First of all, we have two kinds of lines we can use when we graph an inequality, a solid or a dashed line. The solid line is for what kind of inequalities? No, with those two inequalities that have what underneath? A line, an equal sign. So less than or equal to or greater than or equal to, or give you a solid line when you go to graph it. And that means the dashed line are for the other two, which are just less than, right, and greater than. So less than and greater than without the equal sign. So one way I always like to think about it is whether it's an equation or an inequality, if I got the equal sign in there anywhere, that's when I put my solid line. If I don't see an equal sign, that's when I use my dashed line. All right, that's the first major difference. The other major difference is what? What else do we have to do with an equation? An inequation. Boy, doesn't that sound great. An inequality. What else do we have to do with it? Louder. Shade it. So let's say this is my system of inequalities. This dashed dotted line gets shaded up above here. And the solid line, let's say it gets shaded, it's less than, so it gets shaded here. This is the other major difference. We have to shade. But it results in the biggest difference between a system of equations and a system of inequalities. With that system of equations, we were looking for what? That one point where the two lines intersected gave us a specific point. We then put a coordinate x, y. We gave our coordinate for our answer. Is it going to be possible to list a coordinate for the inequality? No, why not? How many coordinates are there in that region? 2? An infinite number. There are coordinates all over the place. Some of them are decimals, right? Or fractions. But there are an infinite number of coordinates in here. So the good news is you don't have to list for an inequality the answer as a coordinate. The bad news is you have to graph it. But once you graph it, what are you looking for? What is your answer? Where the two shaded regions do what? Overlap. That is your answer. Where the two graphs overlap, just like here the two lines overlapped, they met at an intersection point. Here my shaded regions meet at an intersection. So where the two graphs overlap, and I'll outline it in green here, that's what I'm looking for now. So when you're doing your homework or the test, you want to make sure that I know when I'm looking at it that you did it right. So you want to make sure you somehow identify this is my overlapped region. Don't make me guess. I won't guess in your favor. All right, so that's the major difference. And we're looking at why is it an overlap? Because it's an entire section. It's not just a couple of lines, because it's an inequality. All right, so there are two things you're going to do in this lesson. Either one, you'll be given the graph and you'll give me the system of inequalities, or given the system, you'll give me the graph. Those are the two things we're going to accomplish today. All right, let's go back to this. So we're given this graph here. It's a system, and they're inequalities. How do I know? They're not equations. What overlaps? Yeah. How so? What is overlapping? The lines? The shading is overlapping, right? So I know it's a system of inequalities because I got some shaded stuff up there, right? You see the colors, the green and the yellow? So I know it's an inequality. Because if I didn't have the shaded region, what would I have? I'd have a system of equations because I would just have the solid lines. So I know it's an inequality. So I can go ahead and write it down, start it in slope-intercept form with y. Now for me, I always like to work left to right in my equation, which means what would I need next? The sign, right? Alright, so let's pick one of these two. I'll go ahead and pick this top one. I need the sine, then I'm going to need the slope, and then I'm going to need the y-intercept. So my sine, well, it's a solid line, so that means I'm going to know I'm going to have an equal sign underneath. It's either going to be less than or equal to or greater than or equal to. Which one is it? Less than or greater than? Well, you look at the line, where is it shaded? Above or below? Above. So above means greater than. Y is greater than or equal to. Now I need my slope. Well, that's why I picked my 2 points. I'm going to count left to right. I go down 1 to here. Down 1 means, what's my top number? -1 over 1, 2, 3. What's my bottom number? 3. So that's -1/3 x. And then my y-intercept is up 3, so it's plus 3. -1/3 x plus 3. Now I'll do the bottom one. Again, I have a solid line. I need my sign first, so I know I'm going to have an equal sign underneath. This one's a little harder to see. Is it less than or greater than? Which one? I've had both. This is where you go to the x-axis, where the line hits it. Right there, right? That's less than. Y is less than or equal to. Alright, I need 2 points for my slope. I'm going to pick this one here and this one right here. I always like to pick the one on the y-axis if I can, because that's going to be my number for my y-intercept. I mean, not if it's in the middle. If it were like right here, right through the middle of that, it wouldn't do me any good because it would be a fraction. But if it's hitting right on a whole number, I want to use that one. So my slope is up 1, 2, 3, and 1 to the right. So that gives me a slope of 3x. And then my y-intercept, I start here and count down 1, 2, 3. So my slope, my y-intercept is a -3. There's my system. Just work left to right in the equation. So really, what is it? It's a bunch of looking and counting, isn't it? You can do that. Alright, here's our next system. Go ahead and put down my y's. We'll start with the dash line. Is that less than or greater than? Less than. Is it less than or equal to, or just plain less than? It is not. It's just plain less than. See, it's a dash line. Dash line means just plain less than. Alright, let me pick 2 points. I'll use that one there and this one right here. So to go from left to right, go from this to this, I go down 1, 2, and 1, 2, 3 to the right. So that is the slope is down 2, and 3 to the right is -2/3. So I have -2/3 x. And my y-intercept right here is plus 1. -2/3 x plus 1. Now I have to do the other line. This is a solid line, so I'm going to have an equal sign. Is it greater than or less than? It is less than. Pick my 2 points. Let's see, I can use this one here and this one right here. I'd have to go up 1, 2, and 1 to the right. 2 over 1 is a slope of 2x. And my y-intercept is down 1, so -1. 2x minus 1. That's the first thing we'll have to do. Yes? Pardon me? Figure what out? Sorry? Yeah, yeah, that's it. That's the first thing you'll have to do. The other thing you'll have to do is, given the system, or I'm sorry, yeah, given the system, you have to come up with the graph. Okay, who wants to graph the first one? Okay, don't everybody volunteer at once. Thanks, Marie. Come on up. All right, Marie, we're going to do the top one right there. Which number do you look at first? The 2 in front of the x or the plus 2? Plus 2. Plus 2 tells you to go where? Go ahead. Place your point. She started at the origin and went up 2, plus 2. Now you're going to use the 2x. The 2x means to go where? Up 2 and over 1. Go ahead. Is that the only place you could go? Yeah, go ahead and give yourself another one. Down 2 for those of us who are vertically challenged and can't reach that high. Not just you. All right, what kind of line? Solid or dashed? All right, I gave you a dashed line. Go ahead. Now you have to keep constant contact on it, so don't pick your finger up. I'll fix it. And extend it. All right, which way do you want to shade? It is less than. Yeah, so you go to the x-axis, less than, below the x-axis would be this side, right? Okay, go ahead and shade it. Go ahead. Okay, thank you. Did a lovely job. Thank you, thank you, thank you very much. All right, this next one, who wants to do that one? Justin? All right, come on up. All right, which number's first, Justin? Right, where are you going to go for the -3? Okay, go ahead and put your point in there. It will be green. Perfect. All right, from there, now this one's a little trickier because there's no number there for my slope. Right, you put a 1 in it, exactly.
So it'd be
-1 over 1, perfect. So that means from this point you made, down 1 and over 1. Perfect. Yeah, right there. Or where else could you go? But you'd have to go up. Right. So what you did there, you made the top positive and the bottom negative, which the net result is still a -1. All right, what kind of line are you going to have, Justin? Solid or dashed? Solid. Excellent. Okay, go ahead and draw your line. You have to keep constant contact with the board. Oh, that's pretty good. Excellent. All right, last step, we have to shade. I'm going to go ahead and extend your line. Go ahead. No, wait, where you're going. Got to shade it. It is y is greater than or equal to. Greater than, which would be which side? Well, you go here. Yep. Yep. No, it's the whole side, so you can start anywhere. I mean, it can be all the way up there. Just use one finger. Yeah, it works better. There you go. Excellent. Go ahead. Sit down. So, where's our overlap? What color? Yeah, the orangish, reddish looking part, right? So our overlap would be right in this area right here. I'm outlining in red. That would be our overlap. So that's what we're looking for. You've done all this, now you just have to do it twice on one coordinate plane. All right, how about this system? Let's see, I'm going to do this one. Anybody see a shortcut? It's not an equation, so I want to solve for it, but that's a good thought. Okay, you'll see it in a minute. Okay, let me pick my points. See, +1 means to go right here. -3x is down 1, 2, 3, and over 1, or up 1, 2, 3, and 1 to the left. And it is a solid line. And it is greater than, which will be on this side. So I'll go ahead and shade this side. All right, the next one is down 2. The y-intercept is down 2 from the origin. So that's right there, and the slope is -3. So it's down 1, 2, 3, and 1 to the right, or up 1, 2, 3, and 1 to the left. And it is also a solid line. Yeah, how about that? Could I have just stopped at the beginning when I saw that they are parallel lines? Not necessarily, because I'm shading. You can't do that with a system. Now this is less than. So where is it going to shade? Is there any overlap? No. So what's the answer to this? Empty set. There's no overlap, is there? Now you have to be careful with parallel lines when you have a system of inequalities, because what would there have been overlap if this second one, if this one here would have been greater than? Yeah, it would have been overlap just for whatever this is, this -3x plus 1. But since there was no overlap, since they were opposite signs, they went in opposite directions, there's no overlap. All right, so that one was kind of tricky. A college service organization requires that its members maintain at least a 3.0 grade point average and volunteer at least 10 hours a week. Graph these requirements. Now, my first question to you is, why do I only have the first quadrant? Why do I only have, I still have an x and y axis. That's right. No such thing as negative hours, correct? Or negative GPA. Although I've had some students come close to negative GPA. So I'm going to go ahead and graph this line. Members at least a 3.0. Is that at least? Is that less than, or is it less than or equal to? It's less than or equal to. So at least a 3.0, which would be a line like this, right? So it's everything in here. So when I go ahead and shade this, it's all of this. And then they have to volunteer at least 10 hours. That is also 10 or more. So that's also greater. That's greater than or equal to. Let's take the other one. So I go to 10, and I'm a little above it, so I'll fix it. Oops, it's not what I want. Yeah, thanks, Steve. Appreciate it. Shade above it, and we can see right up here, this is where my overlap is. Those are all those students with 10 or more hours a week volunteering and at least a 3.0, which there are some college organizations that will do that. All right. For a wedding reception that will last at least 4 hours, the couple, that's supposed to say wants, it's obviously a typo, wants to hire a band that charges $300 per hour and a disc jockey who charges $150 per hour. The couple wants to keep the music expenses under $1,200. The band and disc jockey charge by the whole hour only. What combinations of entertainment can they have? Well, this is word problems. This is real life kind of stuff. I know that if we let X be the disc jockey and Y be the band, we know that they want at least 4 hours. So X plus Y has to be greater than or equal to 4 hours, right? When we look at number of hours. We also need to know that $300 times the number of hours X that the disc jockey plays plus 150. Oh, no, the band charges 300. I just got it backwards. That is 150 an hour for the DJ plus $300 an hour times Y has to be less than or equal to $1,200. There's my system. Okay, what's the first problem with this system? It's not in what? It's not in slope intercept. This top one will be easy. I go ahead and subtract my x from both sides, and the top one becomes y is greater than or equal to negative x plus 4. Alright, which I can easily graph. Negative x plus 4. Wow. Negative x plus 4. 1, 2, 3, 4. Negative x is down 1 and over 1. And that's a solid line. But it has to be greater than that, so I'll shade up above. So right now this doesn't really mean much, does it? But there are people whose jobs do stuff like this. Figure out, given your cost, what can you afford? Especially when you're looking at a combination of things. Alright, now I need to move this bottom one right here around. I need to solve it for y. So the first thing I have to do is move the x over by subtracting 150x. That becomes 300y is less than or equal to negative 150x plus 1200. Right now it looks bad till I divide by the 300. Since they're all big numbers, it'll end up being a nice inequality with smaller numbers. Negative 1/2 x plus 4. Didn't look like it would be that good, did it? Yeah. Negative 1/2 x plus negative 1/2 x plus 4 less than y is less than or equal to negative 1/2 x plus 4. So the first thing I notice is their y-intercepts overlap. They're both plus 4. Now I have negative 1/2, which is down 1 and over 2. Up 1 over 2. This is also a solid line. Yeah, the difference with this one is this is less than, so I'll shade below. So here's the area I'm looking for right there. I mean, the rest of this is also shaded. But what I'm looking for is the overlap. So if they charge by the whole hours, what combinations can I have? Well, right there. X is the band, X is the DJ, Y is the band. So I could have 1, 2, 3, 4, 5 hours of the band. I could have 6 hours of the band, 7 hours of the band, 8 hours of the band, and still stay under the $1,200. Or I could have 1, 2, 3, 4, 4 hours of the band and 4 hours of the DJ, 1 hour of the band. I was saying that backwards. X is DJ. 4 hours of the DJ, 5, 6, 7, 8 hours of the DJ. Could have 4 hours of the DJ, 1 hour of the band. So I'm picking out the whole numbers in here. We could have 1, 2, 3 hours of the DJ and 2 hours of the band. This one right here is even in there, which is 2 and 2. So anyway, that's all we have for today. This will be your assignment tomorrow. Oh, it's not March anymore. It's April, isn't it? What is tomorrow? April 5th, right? This is on pages 364 and 365. I have a worksheet for you today.